Hello class. You are receiving this video because I'm going to be out a little longer than expected. This is being done in an effort to keep us on track. Last week while I was out, we kind of stayed on track because we took the whole week to do ACT review, tips, and such. If you did not watch the videos, you need to definitely go do that. Our ACT test is, I believe, February 27th, so it's coming up very quickly. The other thing is the practice from last Tuesday was a requirement, and then on Friday you were supposed to go back and make corrections to those practice questions following the video, making the corrections and turning them back in. If you did not do that, I did collect a few today because I was there for the morning today, which was Monday, the 29th. If you did not have those turned in, they are due, they're past due. They will be a completion grade, so make sure you go loop back to last week's Canvas assignments under ACT Prep. So going forward, if you are in honors, second period or third period, we've already done these 2 pages, so you can actually skip to the next video unless you were absent during second or third period today. Or if you're honors 6th period, I was not there because I did go back to the doctor, so you will need to watch this video in its entirety just for a review. Okay, on Friday, January 12th, we actually received this booklet. All my CP classes did not receive this booklet. However, it is lying on my desk and you'll have to ask the substitute to give it to you. It's not folded as a booklet at the moment. You will have to fold it and write this title on the front. And the typed words will be on the inside. So again, all my honors classes have seen this booklet already, and it should be in there unless you were absent on Friday, January 12th. CP classes have not seen any of this, so you'll have to watch it from the very beginning. And again, the substitute will have these. I made sure they were laying on my desk for your use on Tuesday, the 30th. Okay, so let's get started because I do have a time limit on this video software. So if you would pause the video, make your notebook look like this. 65 and 66, that's honors and CP, have the same page numbers. We're going to go over the notes for the remainder theorem on the inside of this booklet, go through a few examples as a discovery that you will not have to write down, and then I'll tell you when it's time to open the notes and actually write down some examples. And then we're going to do these 3 examples together as well. Remainder theorem is pretty simple, so should be a quick video. Okay, so discovery part, you do not have to write any of this discovery down. It's just kind of a way to demonstrate how this works. Okay, so in this discovery, we're basically going to review synthetic division and how we can use it to find a remainder. So we have a function f of x, and I've highlighted it in blue. G of x is here in yellow. So what I'm going to do is I'm going to go the old-fashioned way, and I'm going to find the remainder of this. If there is one, I'm going to find it using synthetic division. Remember that you take this guy here, this divisor, you set it equal to 0, and you solve and see what x actually would equal. X would equal 1 in this case. If you set it equal to 0, you'd have to add 1 on both sides, and it would be x equals 1. This is a root or a possible root or solution right here. So you're going to use that number in the box here. Okay, remember that you list out the coefficients of the function, and they are 1, positive 2, negative 5, and 7. Remember, these should be in descending standard form order by exponents. We bring down the first value, and then we start multiplying and then adding straight down. So when we multiply this guy times everything down on the bottom. So the first one is 1 times 1, and you bounce up here and put your answer for 1 times 1, which is 1, and then you add straight down. 2 plus 1 is 3. Multiply again. 1 times 3 is 3. Add straight down. These are opposites, so you'll get a 2. Multiply again. 1 times 2 is 2. add straight down, you will get a 9. So in this case, I don't even want to know the final answer. You know, normally we would take x to the third and depress it down to x squared, and we'd say 1x squared plus 3x plus 2, remainder is plus 9 over x minus 1. But all I really care about here is the remainder, and you're going to learn why the remainder is pretty important here in just a minute. But the way that we found the remainder was through synthetic division. We'll do it all over again. This time, instead of giving you x plus or minus something as a factor, they've actually already set it equal to 0 like we did right here. And then they've solved it and got a root or a solution. So this time, you don't have this part. You have already solved root or solution. So this is what you're going to use here. Anytime you see x equals, they've already done the solving for you. If you wanted to go backwards and see what factor they started with, then you'd have to take this negative 3 back over to be with the x, which means you'd have to add 3 on both sides. And that would mean that your factor is x plus 3. So this is what they normally start with, and they make you go here. But you could start with the root or solution if they've already done the work for you. And you could always take it back to a factor if you want, or if you need to, which you will in some cases. All right, I'm listing out the coefficients. And then I start multiplying, add straight down, multiply, add straight down, multiply, positive 12 and a negative 12, give me 0. There's my remainder, remainder 0. Okay, so in that example, I used synthetic division. Now, I'm going to do another method, which is called synthetic substitution, or it's also called using the remainder theorem. And I'm going to take the very same blue equation. This is exactly the same as the last one on the screen, and this is the very same yellow equation. And this time I'm going to grab my calculator and I'm going to substitute a 1 in place of all these x's here, here, and here. And it will look like this. F of 1 equals, I'm going to say, instead of x to the third, I'm going to say 1 to the third. Times 2, or plus 2 times, instead of x squared, I'm going to put 1 squared. Instead of x, I'm going to put a 1 and then a plus 7. Okay, and if I type all of this into my calculator, which I can do here, oops, okay, so I will have parentheses 1 to the third power plus 2 times 1 quantity squared, and then I'll have minus 5 parentheses 1 and then plus 7. Okay, and my remainder here was a 5. So when I did f at 1, I got a 5. Okay, so let's just look back. Something's weird. Oh, I know what it was. This was supposed to be a negative 2, because a negative 5, positive 3 would be negative 2. So then when I multiply, duh, mistake. Glad I caught that. It's been a long day. So this would have given me a 5 to begin with. I just caught my mistake. Oopsie, you probably saw it right away. Okay, so I got a 5 here. And when I did it the other way using a substitution method, I still got a 5. Okay, so now check out the yellow equation. See what we got last time when we did synthetic division and did the long, I would call this more like the long way. I got a 0. What do you think we're going to get when we use this method of substitution? Let's see. Oops, that should be called g at 3. So if I want to know what g at negative 3 is, I've got to put a negative 3 in here, here, and here. So I'm going to do negative 3 cubed plus 5 times negative 3 squared plus 2 times negative 3 minus 12. Okay, breaking out the calculator, I would do this all over again. And for g at 3, I'm going to have parentheses negative 3 to the third power plus 5 parentheses negative 3 squared plus 2 parentheses, -3 minus 12. And I get a remainder of 0, okay, or an answer of 0 in this case. Now, you're probably already predicting that this ends up being our remainder also. So let's check it out. Yellow equation. We got a value of 0 here. When we did synthetic division, we had a remainder of 0. That's not a coincidence, guys. This is called the remainder theorem. This is the inside of your little booklet that you should have gotten from the substitute, or you might already have it if you were here on January 12th. And this is a fancy way of saying what we just learned. If you have a polynomial called f of x, and it's being divided by x minus any number, whatever this number is. In this case here, in the first example, would be x plus 3. It's like your factor. If you solve for x, and you take that k value and plug it into the f function. See here, it used to be an x right here. Now it's a k. They're saying solve this for x equals, and you'll get a positive k out. And if you plug it in, the remainder is whatever you get when you do that. So this says the remainder is whatever you get when you plug this k value, or whatever this value is, when you plug it in to the function. And we just did that. We already figured it out. So we're just going to do a couple more for our notes really quickly here. Okay, it says without using division, find the remainder for x to the 4th minus 8x to the 3rd plus 11x, subtract 7, if it's being divided by x plus 3. Okay, so here's my function, and I'm not going to use synthetic division. We're going to use that remainder theorem that says, hey, if I take my function and I plug into it whatever this equals, when I set it equal to 0 and solve it, then this should give me my remainder as a shortcut. Okay, so I'm going to take my x plus 3, I'm going to set it equal to 0. That's this guy. And if I did a minus 3 on both sides, what that would tell me would be x would have to equal a -3. So -3 is the number that's going to get substituted in to the f function. So here I'm going to do f at -3. Okay, and that's going to give me, let's see, -3 to the 4th minus 8, -3 to the 3rd, plus 11 times -3 minus 6. Okay, so then I'm going to get out my handy dandy calculator. You guys can get out yours if you want. You are going to need it at some point. And I'm going to clear this one out. I'm going to type f at -3. So that is this stuff that I find it handy to write it down before I have to type it in the calculator. Some of you are really good and you may not have to do that, but I just like to do it. Keeps me from making mistakes. I still make them, but you know. Okay, minus 6. Okay, wow, that's a really big number, 258. So let me make sure I did it right. 4th power minus that to the 3rd plus 11 times that minus 6, yeah. It just happens to be a really big number. So all of this ended up equaling 258. Right? Right. That's a big number. I'm going to move this up here out of the way so you can still see it, but it's out of my way. There. Okay, so what that means is that the remainder is going to be 258. Now, if I wanted to do synthetic division to prove it, I'm not going to do it because I am short on time here. But you could set this up, use these coefficients. Don't forget to leave a 0 as your x squared is not there, and you can work it all out. See if you get 258. You really should. Okay, so this is just a shortcut way to get our remainder without having to go through all this and get all the way to the very last result. Okay, so let's do another one. Sometimes this is called synthetic substitution. It is the remainder theorem, but sometimes it's called synthetic substitution. It's kind of synthetic because it's taking the place of synthetic division, but you are substituting, so that kind of makes sense, I guess. Okay, find f at -3 if the original function is called f of x and it equals all this. So what they're saying is take out the x that's here. See it? They're taking out the x and they're wanting you to put in a -3. So exactly what you're thinking.